We're going to have the next presentation from Rowan Fenn, introducing BioPass to us.
In the 15th century, the Inca Empire was the largest in pre-Columbus America. This was despite having no form of money, no marketplace infrastructure, and no form of writing. The social and economic structure was based on reciprocity. The civilization is often referred to by archaeologists as a socialist utopia. It was characterized by very effective, very efficient allocation of resources throughout the empire, and very peaceful cooperation. It's attributed to a very unique form of accounting or record keeping that they used, called chronological accounting. In the next century, they were colonized by the Spanish. Records from the Spanish indicate that they appreciated the features of this unique type of accounting, but it was complex, it was hard to travel or to transport. The Spanish were a seafaring nation. They went from continent to continent, and so they imposed central ledger accounting on the Incas. And this unique form of sequential accounting or chronological accounting died out with the death of the Inca Empire. 600 years later, someone by the name of Satoshi Nakamoto reintroduced us to central or to distributed ledger or sequential accounting. My name is Rowan Fenn. I'm the founder and CEO of a company which is based in Perth called IMarEST Technologies. I'm also the founder and CEO of a company in Singapore called Keychain, but today I'm here to introduce you to a product called BioPass, which we're developing in collaboration with Fenn and Clean Subsea. BioPass is the world's first end-to-end digital hull performance management system, specifically designed to address the challenges that emanate from marine biofouling. But before I tell you more about BioPass, I just want to give you some context in terms of what we do at RISE, why we think it's very important, and why we think this technology is very important to the long-term sustainability of our planet. At RISE-X, our purpose is to increase the carrying capacity of the planet. To do this, we build management systems for industrial clients to help them automate value chains and supply chains so that they can produce more outputs using less inputs. From a commercial perspective, this means companies can grow revenue and increase operating margin. But most importantly, it means we can reduce their impact on the planet. So we partner with companies who are committed to applying this technology in pursuit of productivity. Our focus is on waste, and our goal is to remove it. In almost every supply chain or every value chain, multiple entities participate in the process of turning inputs into outputs. Today, processes inside an enterprise tend to be fairly efficient, and constraints from a productivity perspective exist outside your enterprise in the supply chain. We build simple applications to help improve and streamline the interactions and transactions between multiple entities in an ecosystem. And so we build infrastructure to consolidate and facilitate interactions and transactions between multiple stakeholders in any industrial ecosystem. In the back end of our products, we leverage distributed ledger technology. It sits in the back end because that's where it belongs. It's dull, it's relatively boring, but allows us to do some very cool stuff. Predominantly, it allows us to create a common intercompany information record, meaning whenever we're working together in an ecosystem, we're all working off the same base set of information. This allows us to do something called synchronous workflow, meaning we can solve coordination problems in a supply chain. And we can start to automate business processes and commercial processes that cut across multiple entities. This is a remarkable accomplishment. It's very recent, and it's extremely important because it gives us the tools and technology to reconsider, to rethink how we structure not just the digital world, but the physical world. And ultimately will help us to increase the carrying capacity of the planet. It has taken all of human history to build the industrial world as we know and experience it today. Our global industrial infrastructure is the height of our collective human accomplishment, not just of our generation or our parents, but of all human generations up to today. The scope and scale of our global infrastructure is truly awesome, and it's not something that should be taken for granted, even though we most likely do on a daily basis. But more and more we're beginning to understand the costs of our accomplishments, and more we're beginning to understand that these costs are too significant to continue to ignore. We have to increase the carrying capacity of the planet. Population is growing larger, we're living longer, and we're getting richer. The idea that we'll consume less of anything is bordering on farcical. Today, our population of 7.1 billion people consumes 90 billion tons of resources per annum. That's energy, biomass, minerals, and agricultural products. In the next 2 decades, our population grows to about 9.1 billion people, but the important number that you need to pay attention to is the growth in the urban middle class. That's expected to double in the next 2 decades, from 3 billion people today to more than 6 billion people in 2040. That puts us on track to consume 350 billion tons of resources per annum. It's 4 times what we consume today. If we meet that consumption the way that we meet it today, we just scale up our infrastructure, it will be absolutely catastrophic. We have to find ways to deliver those products, those goods and those services to those people who are expecting them, but we have to do it in ways where we use exponentially fewer resources. And we have to try and solve this problem in a way that's as inclusive as possible for as many people as possible. As a father, I sometimes worry about what might happen if we fail to address this challenge. But as an optimist, I spend a lot more time and energy imagining how cool the world will look when we succeed. As an entrepreneur, I'm excited by the scope and scale of this opportunity. In the next 2 decades, we have to reimagine, reinvent, redesign, and redeploy our entire global infrastructure with the goal to decentralize what is a prevailing centralized system today, which ultimately we cannot sustain. According to the latest report from IPCC, limiting global warming to a manageable but still dangerous 1.5 degrees is possible. It's possible, but it requires far-reaching change across all aspects of society within the next decade. The Economist calls this the greatest project humanity has ever undertaken, and they compare it, the scope and scale of this project, to being the same size as World War I, World War II, the abolition of slavery, the Manhattan Project, the rollout of railroads, the introduction of sanitization, and electrification all rolled into one. At no point in history has an opportunity so significant presented itself on a timeline so short and being driven by an imperative which is so existential and so common. It's a borderless problem. At RiseX, we want to build a digital infrastructure to allow companies to automate supply chains and value chains so that we can increase productivity and ultimately increase the carrying capacity of the planet. BioPass is one of these projects, and it's the world's first end-to-end digital platform for hull performance management and to address the challenges presented by marine biofouling. When the problem was presented to us, the question we were asked to look into was how do we address the cost of compliance? It's viewed by industry as additional cost, dealing with guidelines, standards, and in some jurisdictions, regulations to do with biofouling and IMS. There's a cost of trust, so there's a burden of proof on the ship side. There's also a cost of enforcement on the regulator side. At these early stages, there's some ambiguity, a lack of certainty. Who's to say that any intervention I take proactively guarantees me entry into a port or reduces my risk of introducing IMS? And so companies, ship owners, are making trade-offs between lowest cost strategies and lowest risk strategies. And the prevailing wisdom when we're looking at this problem is that over time we'll push that curve towards the center of that graph through a process of continuous improvement under the philosophy of ALAR. When we look at this problem, we ask ourselves if we can use technology to mitigate the trade-offs presented by that problem. And so we ask ourselves, how can we take advantage of incoming regulations, guidelines, standards to build new operations management capabilities that unlock opportunities somewhere else in the supply chain and make it clear or mitigate the risk of choosing between lowest cost and lowest risk strategies. Simply put, we said, can we use technology to invert that curve? We believe we can, and so BioPass is the world's first end-to-end digital platform designed specifically to optimize hull performance. The objective of this management system is a clean hull. At the outset, and because of the stakeholders and the partners that we're working with, the platform was designed to facilitate and capture information about hull interventions. So vessel owners ordering a hull intervention from a service provider, we're capturing that information in digital form, we're providing that information to that vessel owner, we're tracking and tracing who created that information, where they created it, when they created it, in a blockchain so that it's verifiable and can be shared with the regulator at next to no cost. We also look at other opportunities, so we're using IoT technology, and in a pilot that we're running with Clean Subsea, we're using the EnviroCart to capture real-time information as it goes through the process of cleaning the hull. So it captures real-time image information from cameras on board the device. We use machine learning to identify invasive marine species if possible, and then we record those images with that event. It's attached to that vessel for the life of that vessel. EnviroCart also collects biomass and filters that biomass. We send that biomass for eDNA testing. We pump clean water back into the sea, and we take samples of the water at the sampling point. When we get information back from those samples, we can attach information, the results of eDNA tests and the results of water samples to that record, to that event, to that contract in the blockchain. So that if I need to share that contract with the blockchain with anyone, I can provide them with the information they need to make an appropriate risk-based judgment. We reimagined that supply chain of providing services, or husbandry services, hull interventions to ship owners. Not the process itself, the process is fairly standard, but what might that process look like if we apply existing technology that we know works to that process to digitalize it and try and make it as effective and efficient, as automated as we possibly can. So Rachel is our dynamic risk manager. She looks after your vessel from a risk perspective, but she also includes lots of different data, available data. So similar to the work that Richard presented on Wednesday, we can use AIS data to make reasonable judgments about the risk that your vessel carries as it moves from one port to the other. Biofouling risk increases over time, and it decreases when you take an appropriate management intervention. Using technology, we can create bespoke management plans for each type of vessel, and not just what type of vessel, but based on what route it's traveling. And so we help ship owners manage and mitigate the trade-offs between cost, performance, and risk. Sally is a scheduler. She helps us optimize resources in an ecosystem. So she helps us to manage work that's being conducted, which might require multiple stakeholders. And our biosecurity task force consists of a community of collaborators. Our system doesn't discriminate between machines and people. So Eugene, the EnviroCart, picks up information and passes it through. Marilyn, our inspector, is our machine learning algorithm. But we also look to partner with third-party providers who would be interested in contributing information to these records for the benefit of ship owners. Over time, we can build up an organic map of invasive marine species, where we pick them up, where we drop them off, and how they move around the world. And we also want to include in the system over a period of time other information that has to do with biosecurity. Barry's pretty dull, he's a bookkeeper, but we're using robotic process automation and some of the intelligent contract functionality to automate some commercial processes. This takes cost out of the process for shipper operators, and it lowers the cost to serve for service providers. And finally, BioPass is our blockchain contract. We use the blockchain contract to govern the relationship between all the different stakeholders who are participating in this process. It's our blockchain contract that says who's allowed to do what in the system, when. At the end of that process, we can recover that record from the blockchain, and we have an immutable record of events, a chronological series of events. Remember the Incas. It's fully auditable and can be shared with anyone, and this is how we believe we can deliver zero cost compliance reporting. I'll share with you a quick video. It's very short. I'll talk over it while it's playing. It's just a demo of the software. The software is currently under development. We're doing a pilot in January or maybe December this year. So this is a service provider responding to a request to do work. So they're providing a scope of work and a quote in the system, and they're emailing that quote to the ship owner. Ship owner can access that quote, can compare multiple quotes. When he accepts it, we've created a contract in the blockchain. We can start to track this process. Service providers use the system to resource the work. So they add people, they add things, and they add templates. Once that work plan is approved, that job card will go through to execution. We're using the system to help people complete work in the most effective and efficient way. So on site, people are using the application to complete the job. Divers check in, they confirm pre-start safety checklists, they conduct isolations. We can run a toolbox meeting, review work plans, and ultimately, once we've completed the toolbox meeting, we're ready to execute the work. In the execution screen, we've got two screens, a dive log to help the diver keep track of the work, and a work log. This is where we're recording information about the condition of the hull. When the workers are recording that information on site, they can add photos, they can add voice information, they can identify and report an IMS. Once they close that job out, they return the ship to the condition they found it in. And if we go back to the office, we have a digital inspection report. We can attach eDNA information to that report, attach photos. We can submit for review and approval. But once the report is final and ready to go to the client, we can send it directly to the client. This is Barry. On the client side, he's accessing the exact same record, so he can view his information. Once he accepts that report, there's a record of him accepting that work, and that card drops off and it goes to the quality and compliance management screen. On the quality and compliance management screen, we have our BioPass with our dynamic risk rating for our vessel and a fully auditable list of all the transactions, all the hull interventions that I've taken for the life of that vessel. For any interaction, I can go and look at the audit trail and access the report. And when I'm trying to do my compliance reporting or share this information with a port authority, I simply input an email, and then I've given them access to view my BioPass. The system is currently under development, and we're looking to do a pilot where we do the first digital or digitalized inspection report in January. As we look to build out that system, we're also looking to work with people who are interested in participating in that system or who may have information applications which you could contribute to help us develop that system. I look forward to taking any questions. I think I'm bang on time, so I look forward to taking any questions in the break. Thank you very much.